Hi, it's Mike from Mixpix Visuals. Today we're going to be keeping it a little shorter than usual. I thought I'd talk a little about how you can get the most out of your particle systems in Unity 5. We're going to make this particle system on the left look like this particle system on the right, basically. We're going to talk about how that happened, because they're basically the same system right now, just with some minor tweaks. You gotta admit that the one on the right looks a little more vivid, a little more alive, like uh, some kind of vortex thing going on, and like variation and stuff. And variation is the keyword for this tutorial, I suppose. I stumbled across a little tiny button, which I hadn't seen before, Unity, which kind of boosted my work. So I was playing around with the particle system, say this one, to the left, and you know, as usual, I'm gonna assume that you know how to set up basic particle systems, or if you don't, you can watch my other tutorial on that. But now I'm gonna assume you know like the basics. Uh, you're like, yeah, I'm gonna set a start lifetime and start speed and whatever, and then what is this little dot over here? This cutesy little arrow. What is that? What is that? Is that a smudge on my screen? No, it's not. It's the very cool. That's why I call it hidden, because it's hidden stuff behind. Because you don't just have to have one constant number of your speed. You can choose between an array of different cool options. Like if you have random between two constants, then you will give them a starting speed of something to something. Like I can put 0.01 here and 2, and that will make them have like a random starting speed, depending on what you set at those parameters. So that's really cool. In this case, it's like that's just being weird. But if you set it to something a little more sensible, like maybe dots, dot 8 and 1.2, it's cooler. And this, of course, opens a lot of doors. You can do all kinds of stuff. It's just your imagination that sets the limits. What I'm doing right now, and what you shouldn't do, because you will hate me if I don't say it, and if you do it, and you, we're in play mode right now. If I change something, it will be reverted back when we start. But actually, I don't really know why I shouldn't be in play mode right now, because this is just to show you guys. And in worst case scenario, if you do something in play mode and you realize like, oh shit, I'm in play mode, this will all go away. My changes, I have to write down every single digit of this. No, you don't. If you hit the little cog up here and you choose copy component, you can paste those component values again when you hit stop, or when you exit play mode. So yeah, so that's basically what's happening. If we actually disable this one and just look at the other beautiful guy over here, what I've done is I've randomized the starting speed, and the starting size is different. The emission rate, I haven't actually tried that one out, but that could also get some cool results. But and now we're also having, like, you see there's color variations in this. There's some of these guys are a little more bluish, and some of them are a little more like teal. And that's why, because we are using random values between these two color ramps. And as well as the size of a lifetime, yeah, that's what I wanted to get to as well. You can choose random between two constants, but you can also choose a curve, or you can choose a random between two curves. So at the moment, we're changing the size of a lifetime to go like going from the biggest to the smallest in a like a slope. We're also using this little bell curve here, like they're starting kind of small and getting bigger as they go, and then end off being really small as well. And that provides this variation of sizes in the cloud. I'm gonna call it the cloud. Let's call it the cloud. But what I also realized today, actually at work, I started fiddling around with the velocity of a lifetime. The the velocity over lifetime, what it does is it tells you how much force is put into any one axis over the lifetime. So if you have that as a constant, if you put it to like the x-axis and 1, it will constantly go one step in the x-axis. I don't know really what the measurements are. And if you put it at a curve, like if you have this kind of slope on your x-axis movement, it will starting going in the x-axis faster and then slowing down. So you can like simulate how it's a quick force that gets dampened, like something shoots out and then slows down by friction in the air, I suppose. And what I've also done here is I've not just done one curve but 2 curves. And for an example, in the x-axis, we're starting off like going this curve. This is gonna be a little more complicated to explain than I meant to, but it starts off going in the x-axis, and then gradually slowing down and actually going past the 0 limit, and then negative x. So they will go like this and bend, because they go to a stop and then they will keep going that curve. And what I've done with the other curve that it's randomized between is the opposite. So right now we have 2 curves going like this and anything between, which like helps us create this kind of, I suppose, a flame shape. Like I think it's a lot in the beginning, and that's what creates this swarming vortexy kind of effect. So that's really cool. I hope I explained that somewhat okay. So yeah, you can like everything that you see one of these little arrows next to, which is, I wouldn't say all of the parameters, but a lot of them you can play around with and get some really cool results if you just put your mind into it. And I think that'll be it for this time. Stay tuned for more of these advanced particle tutorials. I think next time we're going to talk about sprite sheets and animated particles. That sounds exciting. And if it does, please subscribe and you'll know when my next clip is out. Peace!